This video is going to cover setting up the foundation so that we have two windows that we can move around the screen and where the editor can remember their position through player prefs. To start, make sure that your project has the input system package installed. You can do that by going to Window, Package Management, Package Manager, and then under Unity Registry, search for Input. And if it's not already installed, you'll see an Install button located on the right-hand side. Next, let's open up UI Builder. You can go to Window, UI Toolkit, UI Builder. Now, before we start creating something, let's talk about what this window has. On the left-hand side, we have style sheets. If you're familiar with HTML, this is where you have your USS, which is equivalent of an HTML CSS file. It's a central location to store styles that make up how different elements within UI Toolkit look. Next is the hierarchy. These are the different elements that make up your UI. The library comes with two sections. The first is standard, which is what ships with UI Toolkit. The second is a project tab, which if you'd built any custom reusable UI Toolkit components, they would show up here. So you can actually build little templates, but almost think of them as prefabs that can make up the different hierarchies of your UI elements. On the right-hand side is the inspector. If you click anything within hierarchy or the style sheets, you're going to see the inspector populate with different settings depending on what you have selected. So right now I have just the root UXML file. We can see here that we can change the size, or we can even match the game view of that file. And we can set the canvas background to a color or picture if we want it. Now let's get to building this. Before we do that though, let's just save the starting file. We'll put this under shared, and I'm going to call this GameWindow. And now we're ready to build up our element. To start, we'll create the root element. I'm just going to do a visual element. This is kind of your most basic UI Toolkit container. And we'll rename this GameWindow. In general, our window is pretty straightforward. So we'll just add all of the things here, and then we'll go through and style them so you can see them kind of pop and come alive. So GameWindow is our top level hierarchy. Underneath that, we're going to add another one, and we'll call this content area. This is where, well, the content is going to live. And then under GameWindow, as a peer of content area, we'll add the title bar. And then as a child of title bar, actually need a label to display whatever it is that window is showing. And so we'll add a label called title label. These are very creative names, I know. And that's actually it. That's the general structure of our game window. Now, it doesn't look like much. In fact, we can zoom in a bit here. But we're going to use styles to bring this to life. And with UI Toolkit, there's actually several different ways that you can style an element. First, there's what is known as inline styles. And what that means is if you were to click any one of these in the hierarchy and then go to the inspector and change a property, say, let's go to title label and change the font size, we'll make it 30. You can see two things that happen. One, the label is now 30 pixels tall, but also size itself has become bold within the inspector. And that's an indicator of this property is changed from default. You can right click and do unset, and that'll reset it back to default. Now, in general, I think editing inline styles is bad practice. It's just so easy to get lost in what you have changed and where stuff is at that I prefer to primarily work in style sheets. And this is where UI Toolkit can actually become super powerful. So let me show you. We're going to go ahead and create a new USS. We'll put it in the same shared directory. And again, we will call this GameWindow. And now you can see under GameWindow USS in the style section, it defaults to a root. Anything we were to put here would propagate down to everything. So for example, we can actually set variables here, and we're going to do that. So we're going to set two color variables. This first one we'll call color primary, and we'll set this color to be 140 by 75 by 61. And then we'll do one more color. We'll call this color secondary. I know, super creative. And here we'll do 241 by 220, 186. And it's kind of more of this tan color, which is going to pop on the darker backgrounds. We're going to also set a font asset reference. We'll call this font header. And then we'll do another asset reference. And again, we're going to set this to font. We'll call this font body. And there we go. So now we have in the root 4 variables set that we can reference later. Let's see this in action. Can add new selectors. If you click on the top bar, you're going to see a nice little cheat sheet that walks through different styling selector types. There are 3 main ways to apply styles to controls. The first is by C# type, where you just write the name, such as a button or a label, and that style will automatically apply to every matching control in your UI. The second is by name or ID, which you denote with the hashtag sign. And these will automatically apply to any control that has a matching ID. The third is by defining a style class, which you denote with a dot. And these act as reusable tags that you can attach to any number of controls, and they will all share the same style. Beyond that, you can also use hierarchy selectors to target children at specific depths, and then pseudo classes like hover and focus to change styles based on how the user is interacting with a control. For now, though, we are going to tie some styles to GameWindow. So I'll type #GameWindow. We can see a new one is added here. And remember, this is our GameWindow. It's this giant one here, which is not what we're looking for. So let's add some styles here. The first thing we're going to do is change the position value to absolute. Now, this is going to allow us to manually position the game window anywhere within the game scene's hierarchy. We'll change the width to 400 by 400. And if I hover here, you can see this blue box that's showing you what that width looks like. Now, the reality is this doesn't matter because we're going to set the width within C# on the fly, depending on the types of windows that we're doing. And then we can change the padding on the top of the window to about 20 pixels. And again, I'll come over here and hover so you can see it. Actually, we'll change this value, align items, to flex start. Align items controls where child elements are placed within the extra space of their container. So you can push them to the start, the center, and or really even stretch them to fill the available space. Okay, so that looks good for game window, which really doesn't look like much, but it'll come alive shortly, I promise. The next thing we'll do is content area, which you can see is really not displaying at all. This is where we will drop in, well, the main content. So for the equipment, we'll have the little preview of the character and the different slots that you can equip items to, as an example. The content area is collapsed, but we can make this expand to the full space of the parent by changing the grow property. First, we need to make a new content area style. Then with that selected, change the grow to be 1. So you can see here, nothing's happening, and that's because we need to pop back into game window and then change align items to be stretch. Now, if we come back to content area, we can see it's filling the width of the space. Let's set the background image of this before we do anything else. So we can pick sprite, and I have a background image here, which does not look great. And that's because we have to fix it up, but that is our panel background image. Now we're gonna do 9 slicing on this image. 9 slicing divides an image into, well, 9 sections. So you can see there's 4 corners that are set to never stretch, and then each of the 4 edges can stretch in a given direction, so left and right or top to bottom. And then in the center can stretch any direction. If I hit apply, we're not going to see any difference, but down here we have something called slice scale, and this controls how many screen pixels each border pixel occupies. So I played around with this before, and I found that 0.25 was the right amount for this image. Now, to illustrate this a little better, let's come back over to game window and change the width. And you can see that scaling really nicely, and the corners aren't getting warped. If we were to drop any content within this area, it's going to parent in the top left corner, or show up, I should say, in the top left corner. And what we actually want to do is bring it in padding-wise, left, right, and top to bottom. So we can come back into this and change the padding here to be maybe 15. And if we hover over content area, you can see. So nothing is going to show up in that green spacing unless you have some wonky positioning set to it. And that is it for the content area. So now let's do a little bit work on the title bar. So again, we're going to come back over the style sheet. We'll do title bar. A title bar's position is also going to be set to absolute. So absolute means that we can just set the position anywhere we want. And we saw that content area expand down because now it's not competing for space with its peers. To see this, let's set the background image once again. And then we'll open in. So once again, this is already set up for 9 slicing, but this is around 24 pixels. And I want to say the scale for this was definitely not that. Maybe it was 0.25 as well on this one. Now we can come back up. I'm going to manually set the height on this to be about 40 pixels. That is way too big. Let's go 30 pixels. And then the width is going to be 50%. So 50% of its parent. So it's going to be 50% of the width of the game window. And we can alter the position here by setting this, say, 50% of its parents. Now it's going to always be center of the parent. So to illustrate this again, let's drag and you can see the width is changing and it's always staying center. The last thing is we will set the align items to be center, and that'll force the label to be directly center. Or if we pop back up to top, we could set this to something like 5 pixels, and then that's going to center it. Or we can unset that, and we can pop down to translate and also do 50%. Oops, a negative 50% here. Now, looking at this button, I actually think that the slice scale is a little bit off. I don't think it was 25. I want to say maybe it was more like maybe 15, a little bit rounded. So we'll go with that. All right, the last thing we're going to set is the title label. So that's not looking super great. And we're going to set this as a class. So I'll leave the period and we'll do H1 for header 1. And to assign a class, you can just drag it and drop it on an element, and now it'll apply to that. And there was no change because we haven't actually set any styles. So let's do that now. So the first thing I like to do is set the margin and the padding to nothing. Now you can see it sitting up here. We're going to instead grow. And if we hover, you can see now the height has grown, but the width hasn't. It's not 100%. So we'll change the width to be 100%. And again, if we hover, now you can see it's to the left and it's to the top. We can change this in the text settings in the inspector. So we'll set the middle and then center. And for this, we're going to set the font size to be 24. We could set this as a value within our variables too. We'll make it bold. Letter spacing, I like around 5. And then let's set our font to a variable. So if we right click, we can say set variable. And we could pick font header. Now you can see that's changed. And then I want my font color to also be set. So right click, set variable. And I think we called this color primary. Actually, in hindsight, we're going to take the bold away. I think it's a little too much for this. And that's it. So that's our window setup right now with styles. First thing we'll do is see this within our scene. So if we come back here, you can right click, go to create entity. We'll call this user interface. Right click, go to UI Toolkit, UI Documents. We can just leave the name the same. In the inspector, you can see it did 2 things. It added a UI document component, and then it assigned a panel settings to it. So before we do anything, let's actually see our game window. We'll assign that to the source asset. And now within our screen, we can see that window. You go into panel settings. There's kind of a lot going on here. The most important property that I've run into when doing general UI stuff is around the scale mode. I like to set this to scale with screen size and then give it a reference resolution. 1920 by 1080 is fine. But what you'll see there is that the UIs are going to scale with the screen size versus maintaining the pixels. So if you've got the ability to change the resolution in the game, this is really important. Now, this is worth diving in deeper to understand what a lot of these other settings do. We're not going to cover that since this is a beginner's tutorial. Let's actually delete the source asset because we're going to go about this a little bit of a different way. Let's jump into the code. Rather than typing all of it out, we're going to focus on walking through each file one by one. And ultimately, we're going to need 4 files. We'll be starting with the WindowDragManipulator file first. In UI Toolkit, manipulators are reusable classes that encapsulate input handling logic, so things like mouse clicks or dragging or even keyboard events. You can attach them to any visual element, and they inherit from manipulator or pointer manipulator. So in our case, this is really good for implementing something like a drag and drop. At the top, we have 2 fields that track the starting position of the pointer and the window. IsDragging is used to ensure that we only process movement while a drag is actually happening. Then window root is the actual element that we're going to move, which in this case will be the game window we just created. Finally, panel size and window width are cached values that we're going to use to keep the window on screen. The constructor takes 2 elements, the drag handle and the window root. In our case, the drag handle will be the title bar and the window root will be the entire game window. Target is an inherited property from pointer manipulator and should be set to the drag handle since that's what's going to receive the pointer events. Window root is stored separately because that's what we're going to actually move. So you grab the title bar and that whole window is going to go with it. These 2 methods are overrides from pointer manipulator. Register callbacks on target fires when the manipulator attaches, and unregister callbacks from target is when it detaches. And we're just wiring up and tearing down our 3 handlers, which are pointer down, move, and up. The nice thing about manipulators is that they're self-cleaning, meaning when the manipulator comes off, the callbacks come off with it. When the user presses down on the drag handle, this method will fire. The first thing we do is check if it's the left mouse button, and if it's not, we're just going to ignore it. Then we snapshot our existing state by grabbing both the pointer and the window positions. One thing to note is that we're resolving panel size and window width here and not in the constructor. This is because the layout values aren't available until the element is in the visual tree. Doing it per drag also means that we'll automatically pick up any changes if we ever want to support window resizing. Next, we're setting isDragging to true and calling capture pointer, which makes sure all pointer events keep routing to this even if the cursor moves outside of the element. Bring to front, make sure that the window is in the foreground. And lastly, we're going to stop the event from propagating so no other elements further up the tree will try to handle this pointer event. On pointer move is where the actual dragging happens. If we're not in a drag, we're going to bail out. Otherwise, we calculate the delta, which is how far the pointer has moved since we started, and add that to the window's original position. Then we're going to clamp the position so that the window can't get lost off screen. Lastly, we just applied the new position directly to the window root's inline style. Pointer up is nice and simple. We set isDragging back to false, release the pointer capture that we grabbed earlier, and stop the propagation. Next up is WindowManager. This is the class that actually owns all of the windows in the game. It's going to create them, toggle them on and off, and make sure that their positions are saved between sessions using player prefs. At the top, we have 2 serialized fields, which is a reference to the UI document so that we can access the visual tree, and a visual tree asset for our window template. Below that, window container is the full screen element that's going to hold all of the windows, and windows is the dictionary that maps string IDs to game window instances. That dictionary is how we look up any window later when we need to toggle or save it. In Awake, we grab the root visual element from the UI document and create a new visual element to act as our window container. We are going to set the absolute positioning and the width and height to 100% so that it covers the entire screen. This styling could be done in a USS sheet, but I wanted to show how to do it from C# as well. And the key line here is actually picking mode set to ignore. What this means is that the container is not going to intercept any clicks. In other words, pointer events are going to pass straight through it to whatever's behind it. And without that, this invisible full screen element would eat every click in the game. Finally, we're just going to add it to the root. Create window is how other scripts request a new window. It's going to take an ID, a title, and a default position. The first thing that we do is check player prefs for a saved position using that ID. If the player dragged this window somewhere in the last session, we're going to put it right back to where they left it. If there's no saved position, then we're going to fall back to the default. From there, we create a new game window, which is done by passing in the template, the container, and the title, and we'll set its position. The window will be stored in the dictionary with the key set to its ID, and then we'll return it so that the caller can add content to it. Toggle window is pretty straightforward. We're going to look up the window by ID, and if it doesn't exist, we'll bail out of the method. If it's currently visible, we save its position first, and then we hide it. If it's hidden, we'll show it. Close all windows does exactly what it sounds like. We'll loop through every window in the dictionary, and for each one that's currently visible, we save its position and we hide it. These are our two persistent helpers. Save window position grabs the current position from a single game window and writes it to player prefs using the Window's ID as part of the key. Save all position will loop through every visible window and call save window position on each one. Then it flushes the player prefs to disk with playerprefs.save. And finally, on application quit calls save all positions. This is a Unity lifecycle callback that just fires right before the application shuts down. So this guarantees that we're going to capture every window's last known position. Next is GameWindow. Now this is a class that represents a single window instance. It takes a UXML template, instantiates it, wires up dragging, and then gives us a simple methods to show, hide, and position it. At the top, we have 4 private fields: the window root element, a label for the title, the content area, which we're going to use later to inject custom UI into each window, and a reference to the drag manipulator that we built earlier. Then there's also a public property which checks the resolve display style to tell us whether the window is currently on screen. The constructor is where all the setup happens. First, we're going to instantiate the template and then query for the game window element inside of it. When you instantiate a template, the style sheet gets attached to a template container, which is that outer wrapper element. We don't want to keep the template container. We actually want to pull out GameWindow and then parent it directly. The problem is, if we just reparent it, the styles won't come along. So we will manually copy every style sheet from the template container over to the window root before we remove it. That way the styles stay intact. After that, we're going to query for the title label and content area. Then set the title text. We grab the title bar element, create a new window drag manipulator, which is passing the title bar as the drag handle and the window root as the thing that moves. And then we're going to attach it with add manipulator. We also register a pointer down event directly on the window root so that clicking anywhere on the window brings it to the front. And this is separate from the drag manipulator, which when you drag on the title bar will call it to the front and catches a scenario where the user just clicks on the body of the window. Finally, we add the window root to the parent container, which in this case is the window container visual element that was created in WindowManager. Show and hide are pretty straightforward. Show sets the display style to flex and then brings the window to the front so that it appears on top of any other windows. And then hide will set the display to none. Lastly, set position will write directly to the inline style, left and top. And then get position reads from resolve style, which gives us the actual computed values after the layout. All right, the last file is the UI controller, which really is just a test harness so that we can actually see the Windows system in action. I don't want to dive deep into the Unity input system in this video because that's its own topic. But if you're interested in a dedicated video on that, let me know in the comments and I can put one together. Jumping into the code, we have a serialized reference to the window manager and 3 inline input actions, one for toggling the inventory, one for the equipment, and one to close everything with the escape button. Now I'm just defining these right here in code rather than in the input actions asset, which is what you'd really want to do for a real project. In start, we'll tell WindowManager to create our 2 windows, which are the inventory and the equipment, which also give it a title and a default position. On enable and on disable are where we enable and disable the input actions. This is basically standard input system stuff. So if you were to skip this step, your actions just won't fire. And then lastly, update is going to check each action every frame with the was pressed this frame. If the player presses I, we're going to toggle the inventory window, H will toggle equipment, and escape will close everything. Each of these just calls into the window manager methods that we talked through earlier. And that's it for all 4 files. So go to user interface and we're going to add window manager and then create a reference to the child UI document, our game window template, and then add UI controller to this. And it needs a reference to window manager. All right, and let's push play. And then now we have 2 windows that we can drag and drop around. They change their Z index, I to inventory and H for equipment, or we can bring them back and hit escape. All right, that's it. Thanks for watching. And if this helped you out, make sure to hit subscribe so you don't miss part 2, where we are going to build the full inventory layout. Drop any questions in the comments, and I'll see you in the next one.